Alright guys, welcome to my part 4 of how to solve a 6x6 cube. At this point, all of your centers and your edge pieces should be solved. What you have essentially done is you have reduced this 6x6 into a 3x3. So if you take a look at the diagram I have here, you have this cube here, and you have all the edges solved. I have them here in pink or purple. And the centerpiece here is a 4x4, and that is also completely solved. Now, the corner pieces on any cube are always the same. No matter how big the cube gets, it's always going to have 8 corner pieces. When you reduce it, you have to visualize it as a 3x3. So, looking at it, if you pretend that these lines aren't here that connect these pieces and it's just one piece, then you could think about it as a 3x3. So this is just the centerpiece, this is one edge here, and the corners again are the same. So, this cube that I have here is very similar to the cube that I have here on the left, the 3x3. This is the centerpiece, same as this. It's connected to a white piece, just like this one is. The edge piece is the same. So all you have to do is to solve this as a 3x3. Alright, so before you do go on to solve the cube as a 3x3, you want to make sure that the centers are correct. Red, white, and blue should be in a clockwise orientation, directly next to each other. Opposite of red, you should have orange. Opposite of blue, you should have green. And remember, I was using the white cube in my last 3 parts. Now I'm using a black cube because it's a little easier to turn. So I have the white stickers. But opposite white or black should be yellow. The way that I solve it, there's a bunch of different methods for solving a 3x3 cube. The one I use is outlined in my channel playlist under the 3x3 tutorial. And the way that I do it, I solve a bottom white cross, then you solve the bottom white corner pieces, and then you solve the middle edge pieces, and then finally you will solve the top layer using algorithms. Okay, so as you'll see here, I do have a white cross already solved. When you're solving the cube as a 3x3, you're only going to be turning the outer layers here. You don't want to turn these because you're going to mess up the centers, and then you're going to have to start all over. So you're only going to be turning these outer layers, okay? So what you want to do is you want to form a white cross just like I have here. I'm not going to go into too much detail on how to solve the cube as a 3x3 up to the bottom 5 layers, which is equivalent to solving the bottom 2 layers. But I will go into how to solve the parity errors which occur on the last layer. So once you have the white cross, you want to solve the bottom 5 layers. Now you can either solve the corner pieces by themselves and then solve the middle edge pieces, or if you know how to place the corner pieces with the middle edge pieces together, you can do that as well. I haven't outlined how to do that yet, but I will soon. So just to show you how to put a corner piece down with an edge piece, I have this piece already aligned here. So what I would do, this piece is already aligned with its edge piece, so all I have to do is lift it up, bring it towards me, and then bring it back down. Now you'll see I have this corner piece down with this. And you do that for all 4 corners and the middle edge pieces. And when you do that, you will have a cube that looks something like this. As you can see, the bottom 5 layers of the 6x6 cube have been completely solved, and this is equivalent to having the bottom 2 layers on a 3x3 solved. So what you want to do now is to solve the last layer of the cube. This is a little bit different than solving a 3x3 because there are parity errors which occur when you're solving the last layer. That does not occur on a 3x3 or any odd layered cube. At this point, you're going to have a parity error, or you're not going to have a parity error. What we want to do at this point is to solve the top yellow cross. So, if you see a single centerpiece like this with one edge piece, or if you see a 3/4 cross, that means you have a parity error. If you see the regular patterns that you would see on a 3x3, which are covered in my step 4, then you don't have a parity error, and you can solve the top face. So what you want to do now, if you have a pattern like this, you want to hold this edge piece all the way to the left on top, and you want to perform this move that I'm going to go over in order to solve the 3/4 cross on top. So put this yellow piece all the way to the left, and you do this move. Front face clockwise, top face clockwise, right face clockwise, top face counterclockwise, right face counterclockwise, and front face counterclockwise. And as you'll see, right now I have a 3/4 cross, as I call it. Alright, now that we have the 3/4 cross on top, we want to flip this piece over so that we have a completed cross on top. In order to do that, we need to use that really long algorithm, the same one that we used in the 4x4 cube, the 5x5, and we did see it earlier when we were fixing the edge parity. So what you want to do is you want to hold this flipped piece directly in front on the top face. And you're going to perform this move. It's the same move that you saw earlier, but it's a little bit modified because we're turning a different amount of layers now. Okay, so hold this piece in front and you do all 3 right layers twice, the back face twice, the up face twice, 3 left layers clockwise, the up face twice, 3 right layers counterclockwise, the up face twice, 3 right layers clockwise, the up face twice, the front face twice, 3 right layers clockwise, the front face twice, 3 left layers counterclockwise, the back face twice, and the 3 right faces twice. And as you'll see, this piece has now been flipped over, and we can go on to complete the top yellow face. Alright, so now that I have the yellow cross completed, I want to get the top face completely yellow. So, I'm not going to cover how to do that in this tutorial, but my step 5 of my 3x3 covers how to do that. So, in this case, I do have one corner piece next to the cross. I'm going to hold that in the bottom left, and I'm going to use this algorithm to complete the top. Right clockwise, top clockwise, right counterclockwise, top clockwise, right clockwise, top 180 degrees, and right counterclockwise. And as you'll see, my yellow face is now complete. Alright, now that we have the top yellow face complete, we want to solve the top corner pieces. This is explained in the step 6 of my 3x3 tutorial. So what we want to do is we want to look on the top face for any 2 corner pieces which have the same color on the same face, like these do. Now, if you turn the cube around and you only have unmatched corners like that, that's fine. Hold yellow on top and white on the bottom and perform the algorithm that I'm going to show you once. It doesn't matter where the other faces are. Once you perform that algorithm, you're going to see that you will have 2 corner pieces which have the same color on the same face. It doesn't matter what this middle piece is. Once you have these 2 corner pieces which have the same color on the same face, you put them on the back face, and then you perform the algorithm again to complete all of the top corners. Right counterclockwise, front clockwise, right counterclockwise, back twice, right clockwise, front counterclockwise, right face counterclockwise, back face twice, and right face twice. And as you'll see, all of the top corner pieces have now been solved. And as you'll see, they are not matched up, so if you want to match them up, that's fine. Now you'll see that they're matched up and they are properly oriented. And now we can go on to the last step. Alright, now that we have the top corner pieces solved, you're going to have to check to see whether or not you have a parity error. Now, as I can see, I clearly have a parity error because I have 2 sides solved and 2 sides unsolved. That never happens on a 3x3. On a 3x3, you can have 3 sides unsolved and 1 side solved. If you see that on your 6x6, then you can just finish solving it with the regular 3x3 algorithm. However, now that we have 2 sides solved and 2 sides unsolved, we're going to have to do another parity algorithm in order to correct this. What this algorithm does is it switches 2 top edge groups. So it's going to switch this one with this one. Now, at this point, you may have only 2 edge groups that are switched. So what you would do is you would do the algorithm just to switch them. Since I have 2 edge groups which are directly next to each other, I'm going to do the algorithm to switch these 2 edge groups. When I switch it, the blue edge group will be over here, and the red one will come onto this side. And then I will have 3 edge groups which are unsolved. So, to switch these 2 top edge groups, I'm going to do this algorithm. Top 3 layers twice, all 3 right layers twice, the up face twice, all 3 right layers twice, the right face twice, the up face twice, all 3 right layers twice, and the 3 upper layers twice. And as you'll see, now I have 1 side solved and 3 sides unsolved, which is a case that happens on the normal 3x3, and I could solve it just like that now. Okay, so now I have one completed side and 3 incomplete faces. Now, this is a very common case that you'll see on a 3x3, so you should know how to solve this. I'm not going to go into detail on exactly what I'm doing, but I can see that these pieces need to go clockwise, in a clockwise direction. So holding this on the back, the completed face, I'm going to do the following algorithm. Right twice, up, right clockwise, up clockwise, right counterclockwise, up counterclockwise, right counterclockwise, up counterclockwise, right counterclockwise, up clockwise, right counterclockwise, and that has completed the cube. If you have any other problems, or if you don't know exactly what I did, you should refer to my step 7 of my 3x3 tutorial. Alright guys, so I hope that the part 4 has helped you complete your cube entirely, and I would ask if you have any questions or comments, please leave them below in the comments section, and thanks for watching.